This is Josh White with JW Math Tutoring. In today's video, I'm going to show you how you can use Desmos to hack the digital SAT math section, specifically on Bluebook Practice Tests number 9 and 10. So let's go ahead and get right to it.
Life is a dream the calculus could never predict.
You could, of course, do this in Desmos. It's actually not going to be a lot of work because we're just going to do 24 squared, 21 squared. We're going to do regression because we want to use D, and we just do this. And, oh, I need to remember, it's not giving me that, I need to square this, of course. There. Now we have D equals 113. That's the answer. Just type the Pythagorean theorem equation. It's Desmos, but I used a tilde for regression. It's 113. We can move on to the next problem. Okay, so in Desmos, first thing I'm going to do is just type the A equals 230% of B statement. I'm going to define B as 100. I'll explain why I do that in a second. Then I'm just going to do A. I'm not going to do an equation. I'm going to do a regression. A is 60% of C. The reason I do a regression is because that will find the value of C in order to make this statement true based on the value of A that it's grabbing from the first statement, which is based on the value of B of 100 in the second statement. Now, when I do that, notice I have the correct answer for C. The answer for C right now is the 383. It's the answer to the problem. Okay? And the reason is because since I defined C as, T% of B, and B, well, sorry, C is P% of B, that's given. But because I defined B as 100 in the problem, basically, this number right here is going to be my correct answer. Because this is the percent, this is basically the percentage, out of, not out of, but, multiplied by B or multiplied by 100. The point is, if you picked a different number for B, then you would have to do additional work to solve, that for C is P% of B. But because you do this, but because you define B to be 100, therefore, essentially the C value that we get is just the answer. Because if you think about it, C is P times B, right? So if I set this to 100, whatever this number is, it's being multiplied by 100. So the multiplying by 100, the reason, since I set B to 100, multiplying this number by 100 turns it into a percentage. In other words, it turns it from like the decimal P into the percentage P. And then that, like, the percentage P is just equal to C. So that's why 383 right here at bullet point 33 is the correct answer when I set B equal to 100. So that's the key to this problem. That's how you could do the entire problem in Desmos. Let's go to Desmos and do it in there. So what I'm going to do is I'm going to graph y equals left side, y equals right side. And then I'm going to look for the intersection points, and I'm going to see, excuse me, which of these values I find on my graph. Now, make a slider for A, but notice A has to be greater than 30, so I'll just set it to 31. It doesn't have to be an integer, but I'll just, whatever, set it to an integer. Okay, so now let's zoom out a little bit to see what's going on here. Okay, so where are my solutions? Okay, I have 32 and 29. So right off the bat, 32 and 29. So it looks like 29 is going to be one, since I see it at least for this example. And now what is 32 relative to A? Because if A is 31, then 32 would be just A plus 1. So it looks like it's these two, but let's just move the slider and confirm. So let's bump this up, whatever, just to 40. So if you notice, the 29 stays as a solution. Like this, right here, it keeps intersecting it, at 29 comma 0. However, the other one moves, but notice it's always one more than my a value. Here it's 35.7 versus 34.7. Here it's 35 versus 34. So this is how you could determine in Desmos that yes, 29 is a solution, a plus 1 is a solution, therefore it's letter C, 2 and 3 only. Here's how you could do the entire problem in Desmos. First, we create a table. In that table, you only need to enter the 12, 0 point. You don't need to enter the vertex point because that point is going to be, those values are going to be entered in for h and k. So again, h is 6, k is 302.4. Note, the quadratic regression for like the linear, or not for linear, for the automatic regression, like little button up here, notice it didn't show up because I only entered 1 point, but if I'd entered 2 points, the automatic regression thing would pop up. The quadratic regression by default is standard form. It does not have vertex form built into it. So this you do have to type by hand. All right, so now we get A. So now the question is, what is this equal to when x is 10? So there's two ways you could do this. You could just do f of x equals a times x minus 6 squared plus 302.4, and you could say, well, what is f of 10? It's 168. That's one way to do it. Or an alternate way is you could technically just go x equals 10, and then you're going to have to zoom out here and see where they intersect. I mean, it's kind of tricky, but eventually if you click around there, you can see it makes a clickable point. Okay, what is its depth when x is 10? It is 168. So that is just confirmation of how you could do the entire problem, again, in Desmos. Now, let's take a look at Desmos. So what you're going to do is we are going to graph out the entire equation, and I'm going to do y equals left side and y equals right side. It takes me a little time, to type in the full thing. Okay, now I'm going to add a slider for C. Okay, there we go. Okay, so we're looking for where do these two things intersect. Okay, so we got one here, we got one here. So let's just export those. Export, okay, and we're only concerned with the x value. So I'm just going to delete this. So notice it's just plus and minus the same number, right? So now what we do is we go through and we check each answer choice and we see which answer choice equals one of those two numbers. So A, does that equal it? Nope. Okay, does B equal that? Nope. All right, let's go to C. 39 squared minus C squared. No, kind of close, but no, it's not the exact same number. That's what we're looking for. And then in D, okay, notice here I have the exact same number, negative 39.04625. It matches this basically intersection point, right here. So correct answer for this one is going to be letter D. Again, this is how you could use Desmos to solve the problem. So the way around this in Desmos is you have to solve these systems of equations like this using regression. Here is how you do it. We start a bracket. We type the left side of the first equation, then a comma. Then we type the left side of the second equation. Also, I just realized I forgot to put the subscripts for x1 and y1. Okay, end my bracket, then the regression sign, the tilde. Then a new bracket, right side, comma, right side. Close the bracket. Notice, here are my answers, okay? These are stored as the exact values. Even though y1 shows you the same number that you had when we clicked on the point, it's actually the exact value of 3/7. And here's how we know that. Now I'll do 8x1 plus 7y1. Gives me the exact answer of 3. This is the answer you're supposed to get. So when you have problems, like basically when you have a system of linear equations, if one of the solution values, x coordinate or y coordinate, is a fraction, and meaning a non-terminating decimal, you have to solve it using regression to get the exact answer. Especially if it's a free response. If it's a multiple choice, obviously, then, might not be that big of a deal. But for free response, absolutely, you need to solve it using regression and using this technique. Now, if you want to do this in Desmos, essentially what you're going to have to do is you're going to have to replace the x and the y with different letters. So I'm just going to do A and B. So I'm just going to make a note. X is A, Y is B. All right. And then we're just going to match the values of the expressions. So b plus 12 divided by x minus 8, sorry, a minus 8, and then plus e times a minus 8 over, let's see, it's going to be a squared b minus 8ab. Okay. Now I'm going to add some sliders. Just move them to whatever random values. And now you could go through and you can type in all the answer choices and you can see which ones match and which ones don't. I will show you that C matches. So notice I have the exact same value here. I'm not going to bother going through and typing all of the uh, incorrect answer choices just to save time, but I will show you just an example. For example, if you tried letter B, okay, where you have, it'd be AB and then plus 9B plus 12. And on the bottom, you have a squared b minus 8ab plus a minus 8. Okay, you can see here you get a number which does not match the same value we get up here. Therefore, those two expressions are not equivalent, not equal to each other. So this is how you could do it in Desmos. Again, it does take some time to like go through each answer choice and type in all the expressions and remember to say replace x with a and y with b or whatever letters you pick. But it is an alternate solution method that you could use. Okay, now we can also solve this in Desmos. So what we're going to do is we're solving for Q. I'm going to type in the entire problem as written, the original equation. Okay, except the letter we're solving for, which in this case is Q, I'm going to replace that with Y. Then I'm going to add sliders for the other 3 letters. This is like step 2. I'm just going to move them to whatever random numbers. Okay, there we go. So notice now on my graph, I have a horizontal line. Basically what I'm going to do is I'm going to graph the answer choices, and those answer choices are all going to be horizontal lines. One of them is going to overlap this current one, the red one. The other 3 are not. The one that overlaps is my correct answer. So let's start with the first one, P plus R plus S. Does this overlap? No, it does not. Therefore, A is wrong. Okay, B is the exact same thing, but just stick a 20 out here. Well, no, that's not even going to be on the screen. It's way up here, there. Doesn't overlap, not the correct answer. Let's check C. PRS over PR plus PS plus RS. Notice, yes, the blue completely overlaps the red, therefore it is the correct answer. I'm not going to bother checking D because I know it's wrong, but in theory you would also do that. Just whatever. I'll do it. Put the 20s in down here. Okay, this does not overlap, so this is not the correct answer. So again, that's how you could do this in Desmos. You type the original formula, you replace the letter you are solving for with Y, or you could also do it with X and it would be vertical lines instead of horizontal, but I choose to do Y. Then add sliders for PR and S, move them to whatever. Here they just have to be positive, that's all that matters. and then type your answer choices and you see which horizontal line overlaps the existing line, and that is your answer. Okay, now you could also just solve this entirely in Desmos using a slider because they tell you that it's an integer. So, for example, you graph y equals left side, y equals right side, all right? And then we set k whatever equal to 1. So notice, basically, what I'm looking for as I increase the value of k here, I'm looking for no real solution, meaning in this case, because I'm grafting two things, no solution means there are no intersections. So like notice right here at 49, they intersect or they touch, okay? That tells me 49 is not the answer. It has to be the next smallest integer, which is 50. So this one could be solved entirely in Desmos, but only because they tell you it's an integer, because if it was not necessarily an integer, then you're getting into decimals and all those kind of things. But yes, you could solve this one in Desmos as well, just by basically using a slider and seeing graphing y equals left side, graphing y equals right side, and seeing where they do not intersect.